evaluate the limit as n tends to infinity of the sum from I equals 1 up to n of 1 over n times 2 minus I over n using geometry. Okay, so the geometry here is kind of interesting because this, I mean, you can sort of tell if you're passingly familiar with first principles integration, this is some definite integral. So, why shouldn't I use all the big, advanced, powerful integration techniques that speed things up to answer why can't I use integrate? Well, this is sort of a question I think that's testing, do we understand the humble origins of the definite integral without all the big advanced stuff that, some that we might know, some that we don't know, that someday we'll learn. Okay, but this is one where we're going to have to use geometry. Now, we do still have to recognize, hey, this is a definite integral. And so the plan here is we're going to go from the limit to the integral, but we're not going to actually, integrate it, but we're going to recognize it as a shape. And then we're going to use geometry. That is the goal here. Because, so for geometry, I'm going to expect that this is maybe the shape of a triangle or a semicircle or something like that, some shape I recognize with geometry. So we're not going to use integration to answer this sort of area problem. We're going to recognize that this is something we can do with geometry somehow. Okay, so let's copy this over and try and figure out, okay, first of all, what is this shape? And we're going to have to, I think, go do the definite integral bit first. Because this is really sort of screaming, hey, I'm a definite integral. So it was 1 over n, and then I think it was 2 minus I over n. I want to double check that before we continue on, as you always should when copying from an official question to your scrap paper. But okay, we're good. We're good. So this has to match up with some a to b f of x. And once I know that f of x, I can probably sketch the graph real quick and recognize the shape. Okay. So what actually is it, though? Well, it's a first principles integration, which looks like fxi delta x. Okay? And so from here, we should be able to work out just the f, the a, and the b. That's all we need is the f, the a, and the b. And, well, what is the delta x? Well, delta x is b minus a over n. The xi's here are a plus I delta x. Okay? And so if somebody comes along and says, hey, here's this limit, does it match with a first principles definite integral? How exactly do we go about doing it? So the first thing I do is I take a look for two things. I look for any i's, because those i's are only in the xi formula, which means they must be inside the function. They must be part of the xi that is somehow being plugged in. Okay? The other thing we look for is something small and simple multiplied off on the side that looks like something over n. Well, we've got that. So the order here is kind of reversed. I usually write fxi delta x, but yeah, we can see by matching things up, the delta x has to be 1 over n. And that means that b minus a has to be 1. Okay. Now, it doesn't tell me what b is. It doesn't tell me what a is, but we're getting there. The other thing we see, we've got I over n. Well, I over n is I times 1 over n, which is I delta x. And I don't see anything added with it, so I feel confident in saying, okay, the xi's are 0 plus I times my delta x. So they're just I over n. Now, this is one of the things you can do. You could pick a different a. There are choices. That'll shift your b and will shift what your function is. But I think something simple like a equals 0 is fine. So if a is 0 and b minus a is 1, then that means b is 1. And once I realize, oh, okay, I'm saying that this whole expression is my delta x, or not my delta x, my xi, then that means the rest of this left over must be my fxi. So that's a dot. So that's 2 minus xi. So what should my fx be? 2 minus x, right? Just replace the xi with just x, and then we've got our formula. So the limit that we've got, we'll write it again. So from I equals 1 up to n, if it was 1 over n, 2 minus I over n. This is really the integral from 0 to 1 of 2 minus x dx. Now again, we're going to pretend we don't know any integration. Maybe we don't know any integration. Maybe we know tons of it, but we're going to avoid it because we were asked to do this question with geometry. So we got to say, well, what shape is this? What shape is this? Well, sketch a quick graph, right? Knowing what the definite integral represents, an answer to the area problem, we're going to go from 0 to 1 under the 2 minus x curve. So 2 minus x, so we'll graph y equals 2 minus x. Well, that's a line with y-intercept of 2 and a downward slope, so something like this. Plugging in 1, we'll see we're up here at a height of 1. So 1, 1 is a point on here. 0, 2 is a point on here. And the integral here, this definite integral, just represents this area right here. So we say, hey, do I recognize this shape? Well, it's not quite a rectangle. It's not quite a triangle. This is a trapezoid. It's actually a trapezoid sort of on its side. Most people, when they see trapezoids, they draw the parallel sides on the top and bottom. But we have these nice straight lines here. This is a trapezoid. Now, if you know the formula for a trapezoid, go ahead and use that, right? That's exactly what I'm going to do. If you're sitting there saying, oh, wait, I don't remember the formula for a trapezoid, nice thing about trapezoids like this, you can break it up. You can say, look, this is one triangle over one rectangle. And say, well, okay, I do know the formula for the area of a triangle, and I do know the formula for the area of a rectangle, just add them. Just add them. So this is a 1 by 1 rectangle and a base 1, height 1, this is height 1 here, base 1, height 1, triangle. So you could definitely do that, 1/2 plus 1. But for the trapezoid, I think I'm just going to straight up use the formula because I know it, and hopefully you do too. But again, if not, that's okay. So what's the formula for the area of a trapezoid? It's 1/2 height times the sum of the two parallel sides. So 1 here, 2 here, and the height, going from 0 to 1, the height, which is on its side, it looks like a width right now, is 1. Okay, so we just plug that in. So the area is 1/2 height of 1 times 2 plus 1, the parallel sides. So that's going to be 3/2. So that's the area of this shape, which is what this definite integral represents, which is what this limit is expressing. So there we go. So our final answer here, this thing all evaluates to 3/2, but we didn't use any summation notation formulas. We didn't calculate any limits. We didn't use any super advanced, I don't think you even need super advanced integration techniques. We just resorted to recognizing this as an integral, recognizing its shape, and using plain old geometry.